Hello.
Hello.
Hey, how are you guys?
Let's get set up here.
I made a page for the Raha paper too. In Notion.
Okay. I think, did we actually finish the other paper? I think we did. I think we kind of started glossing over this paper last time.
Yeah, I think we finished the last one.
Yeah, okay. That was a nice discussion on all the different. That was a mechanism one from Lee. Just to kind of briefly go over what we did last time, we talked about. Oh yeah, that was the one where it was like the cybernetics question. I know him well enough. I want to look at his stuff.
Yeah, he was cited in.
What's that?
Are you talking about with Turvey?
Yeah.
I said he was cited in the Raha paper.
Yeah, he came up a lot, and I want to learn more about his stuff because I don't really know it that well. But yeah, somehow I muted myself there. That's weird. Move this stuff over here. What is this? Okay. So, we talked about Piccanini. We talked also about somebody else too. I know you posted a lot of things in Slack. This paper, the beer paper, and then Michaels and Corelio here. Any thoughts about those?
No, they were just interesting citations. The direct perception one is a collection. And we might have talked about, I know we've talked about Randall Beer before. We might have talked about this paper.
Is he Stafford Beers?
No.
Or just totally different?
I think it's a different one.
That's great.
More of a craft beer than a mass market beer, maybe. I don't know.
As long as they're all, getting along, whatever, have a good time. Like, who was the one who called for that? The one, was that Richard's paper? Anyway. Yeah, there were so many citations in the Raja paper that I'm still kind of wrapping my mind around, and I feel like, yeah. So I don't know. I'll go through the Slack fully, but any general updates? I think this is gonna be the last meeting before Amanda's break, and then we'll take a break in general, so it's fine. I may meet, maybe not next week or whatever. I may meet with Bradley to talk a little bit about some of the cybernetics stuff, like administrative things, not really not going to be like reading papers or anything like that.
Right.
But I have some ideas I'll get into later about other tangential projects. But that's the only thing really on my mind about like the time away. I'm very okay with just having like a few sort of, I take a break too from doing this. So I don't think there's going to be a lot of action. Anything else we want to say before we go through the Slack or whatever? As a kind of a side note, I'm getting kind of a lot of like non-committal replies to things about the cognitive science event. CogScience 2023 that's happening in Australia, but also I've advertised some stuff for like, let's meet up here in Boston. And between that and the fact that I have like two family things. One of them's like health related, one of them's wedding that I'll be going to next week. I'm not really going to be around here, so I don't. It increasingly looks like there's not really much going to happen that way, which is fine. But I still want to follow. I would really like to follow. I still want to kind of go through that thing from last year about the trends in it, just to kind of. We didn't really talk about that. I think some of the papers were a little bit like kind of questionable seeming, so we kind of got sidetracked with that. But I still want to look at that. I still want to like follow the event. But it's interesting because my mind is obviously kind of other places about that.
Right.
I guess what I'll say in terms of project development sense here is there's still the cybernetics project thing. I don't really want to call it, and all this stuff. I don't have like any major preparation for that, but more I think cybernetics is an interesting case study, almost not because there's an answer to it to find, but more just it's such a like a quagmire and a mess and so murky and so indirect that it's like a good space to just practice some of the art of following or developing or considering theory. Like that's sort of my appeal to it in some ways, believe it or not. And I feel like it dovetails for me into some of the general cognition future stuff broadly, but also I'm kind of thinking about this, like I mentioned this to Bradley, I think somewhere in Slack or something. I'm thinking about you know, I posted a few different books in I think I put it in here too, actually. Maybe in here. Yeah, like I cruise around for books like that are kind of about this, like this book, The Crisis in Physics, and maybe the Science and Creation book was a little extra, but and The Forgotten Revolution. These books are specifically about like these trajectories of how science evolved, and kind of like touching upon some of the Kuhnian projects and ways of interpreting the development of things and what's going on and then what's happened and what's why. And like this book was written, I think, in the late 30s or something of that nature, and I'm starting to get a little better sense of how people thought about stuff. What was a zeitgeist? You know, what was the thing about? A lot of Norbert Wiener's writings are, you know, as we'll say tomorrow again, is along the lines of post-war sentiments or Cold War sentiments. And I know we kind of talk about that, but I'm gaining a little more empathy for it in the sense of how things have developed in that way. I didn't get all these books, but like these books, I think this one is about the like Enlightenment period. I don't remember. This one's obviously a little bit about the whole realm of things. This is interesting because there's actually there's like a limited availability of English translations of this. I found one online because it was still, I think originally this book's like still $100, and at the bookstore it was like half of that. And I was like, I don't think I'm going to buy that right now. But I'm spending a lot of time in this sort of philosophy or history of science realm, and I feel like I'm brewing a project there in a broad sense that's not just about cognition studies, which is kind of the main thing that I am concerned with, but more like how is the whole, like, well, I have like some ulterior motives about it too. Like, there's things I want to do that I'm not really ready to talk about yet down the road. But more generally, like, how are people talking about? How are people doing, like, the history and the philosophy of these sort of the things that are influencing the developments of it? And like, I have my own views about stuff we talked about, including like, oh, the modern day Norbert Wiener would say XYZ and all other stuff we said in that space. And I want to kind of become more informed about some of the historical lenses people have used as I juxtapose my own views to that. But that's not really that's a little further down the road. But I think in the short term, I am kind of, there's something I want to do that's along these lines, and I don't quite know what it is yet. And I've kind of started talking a little bit about it to Bradley on the side, and I don't really have anything to say. Like, I would love to make an internship posting. Oh, are you interested in the history of science or like technology, or like specifically not just the developments, but like that which the environments in which the things were taking place, which I guess is the history of it, but not just like, I don't know. Anyway, there's something to go on there, and I don't really know what it is yet, but I think that's going to be another issue. I guess the only thing I'll mention here is, semi-related. This is more of a lab update. I think Bradley saw this, but like, there's this one about GTP stuff, which is like a micro version of this, like all the different ways that's going to be used. But also, I put this in, I forget if I put it in the REL Discord or not, but I'm interested in finding some ways of tracking, like making kind of a task board, or a little bit more functional way of tracking a task board, or having a relationship between, like, on Discord servers, you can like automate some stuff or have things sent to a specific channel. So you can do that in Slack too, but I feel like I don't want to invest in Slack.
Right.
With a way, like, I don't want to put functionality infrastructure into it, because it just, it goes away too fast for things. So I'm thinking about that too, in like an administrative sense, like to be a little bit more concrete and to go back to the current project at hand, Creation Futures. I would love to make a little more functional, like, task board of, hey, wouldn't it be great if we had this? Because we're kind of at that stage here, and there's a lot of smaller, underdeveloped projects in the lab that could use a similar, like, ticketing system. And we've gone about this many times. We've used GitHub, we use XYZ, and I know, and I'm just kind of on a periodic, is there a better way I can do some of the things now? And it will pass. So I'm not like totally beholden to that quest, but just to kind of mention all that stuff.
Yeah, I was experimenting with a local GPT instance, or like, trying to set one up on a local computer to see what it looks like. And, some of them you can train them. It has like its weights that are general, that are trained on data. But then you can also put a set of papers in, so you can upload papers and build a library and then train it on that as well. So I was working on that. It's very hard to run like locally. You need a pretty decent computer. You need like something like a Silicon Mac with, you're going to use up a lot of hard drive space to install everything you need to do. but it can be done, and it might be worthwhile, at least to some extent. I don't know what, we'd have to come up with a strategy of how to use it, but, I think I mentioned that on Saturday, but I think think about it. Like, I know you posted something somewhere, I think Twitter or something, where you said, oh yeah, by the way, we were looking for people interested in this.
Mm-hmm. Oh yeah. And there's even the Levin bot, right? Like that bot that's trained on this paper and other things like that too. And I'm going to eventually incorporate that into some of the We Robot presentations about Frontier Map. But I'm really curious what you can do. I'm very curious what you want to do with that. Like if you want help with that, or I don't know, I'm happy to help with that too. I appreciate looking at that version of it.
Yeah.
At the same time, I don't know. I have an old desktop computer that's not great, but I could get a few more components to it. And I could use that for something like that too, if it's very intensive for what it requires.
Yeah. Usually you need a GPU, but you can run versions on a CPU depending on what your CPU is like. So, the more memory you have, the better, because you could run it for hours and still not get an answer of any type. So, it's a little, you need to have a pretty decent computational power to do it. I know they say it's a local machine, but,
Yeah. Okay. We can talk more about that Saturday and stuff too.
Yeah.
Sorry. Finishing this here. Let me check this thing too. I have a list. There's a really cool, so the other thing I'll say is there's kind of a cool I'm not going to say too much about this because it's basically Jenny from Plot Twister. I guess it fits. I guess it fits with the what's the latest cybernetic stuff from last time. Jenny's really interested in. I can't remember what it was, but totally spelled that badly. Interesting. There was someone she wanted to work with at Edinburgh, and I don't know. There was something about it, but she was very excited about it. And what I'll say here is just there's sort of an interesting. This isn't right at all. There's another potential project about tech ethics somewhere in development. I don't really know how to say what it is or talk about it yet, but it's interesting. Here we go. And so I have this. You can't see it. I'm not going to go to the camera now. But I have this it's almost like a big sketch pad, but it's like a giant Post-it.
Yeah.
But sheets of them, it's 2 feet long, and I'm just mapping out a bunch of things that are projects, and then some of the tools and implementations from them, and then specific aims in them. And I'll show that off more in a little bit. There's I don't know, there's some stuff there, and I guess it's a little too raw to really to say much more about right now. But I don't know. Any comments or questions about sort of I guess you mentioned cybernetics and history of philosophy and science or stuff. Any questions about that before we just go into the paper?
I don't have any questions, but I think that's an interesting project. I have read Kuhn's book a couple times now, but I'm pretty unfamiliar with any other philosophy of science, basically.
Yeah.
Looking into cybernetics could be a good way to broaden my knowledge of the philosophy of science.
A lot of this has come up in the context of frontier map and writing the paper and what citations I want in the paper and how I want to present it at the robot. And basically, I just realized that there's all these different. I want to be a little bit more literate in that space, just so I can talk about it, because I know what I want to say. I know where I want to go with certain things, but I feel like I have to figure out, like, triangulate. Okay, given given what's happened and where we've kind of gone with this theoretically to an extent, like the conventions of this outlook, which are what they are, maybe not that great. I have my views here, and I want to push towards my views in this way. I want to. That's basically what I want to do. And it's a sense of, how, with the frontier map stuff specifically, there's a sense of, I don't know, and this is probably another conversation. I apologize for bringing it into here, but like, I think I might request a administrative meeting about frontier map stuff, because I want to make like a very simple, accessible version, and then I want to do a much deeper like you were thinking about, like open science initiative, open science framework, and making like a project space or a ResearchGate space that has the different versions of things. It's like I have a bunch of questions about how I should do it, because the really well researched and heavily cited version of this form, comparing to Kuhn and Rousseau and these other people that I've been looking at, looks different and hits differently, and is a little bit like the point and the references are different than just here's what you do to make a frontier map and here's why it matters, And it's sort of that end of things a little bit. I'm still feeling it, so I don't know.
Yeah, I think that's a good idea. We should do that soon. I think I remember, like, when you were shopping around. Remember when we had those cards and we were shopping around like different projects for people, and we were getting CVs and things like that. And I think you had a couple people who were interested in history, like if you describe the frontier map to someone, it's like it comes out that some people who have history backgrounds are interested in that, because that's kind of what that is in a sense. So yeah, I think there's I don't know if you remember that. That was like probably almost 2 years ago now, maybe.
Yeah,
we did the
first
cards.
Started talking about it.
Yeah.
Yeah.
So I don't know. I mean, like the way you were talking about it then was, and that might be something that you want to try to look in that direction. Find someone maybe with like a history of technology or a history of science background or philosophy of science. A lot of times those things overlap. So, I mean, that would be fine. I don't know what your plan is, if you want like to have like a history or a sort of a component like that, and then like a technical component, or if it's just, it's hard to find someone who has all those talents in one package. So, you might you might split those up a bit, but
well, that's the thing too, and that's why some doesn't to be right now, but
yeah. But I mean, yeah, we should have a meeting soon. I would just like to see where you are with that. I don't know. I mean, like we've talked about it, but it'd be nice to see like a draft of it where we can go over it a little bit. And
yeah, the paper itself is still kind of in outline state, but then there's kind of what I'm trying to do, even just for myself, is differentiate the huge problem space, and then I don't know if I'm going to make any like research artifacts about the problem space as a whole, which kind of is like all of history of science, versus like, I don't know, like making a kind of a working group around that space, and then saying, okay, in this history of science shorthand term for that, we're having these projects in there. Like I'm trying to differentiate that out because I don't want to shove everything into frontier map because that's not really what it's supposed to be. But there's other stuff that are like theoretically relevant and like pedagogically, and I don't know what else to say. Kind of education banner-ish, but maybe not. So all that kind of stuff. So that's the kind of stuff I'd like to talk about too. And we can do that. Thank you for making this Amanda. That's pretty much it. There's more I could say, but I'm kind of just dragging along. I don't know. If you guys want to only do an hour today, that's fine. I know I just took up half of it, so selfish that way.
I mean, I'm up for the full time. I don't know about Amanda.
Let's say 9:45.
Okay.
Yeah, if we go through this fast for some reason, that's fine. But here we are. We're in Roger's paper. Talked a little bit about it last week. But basically, I really like how he situates it. I really like the way he explained. I want to use this. The way he was situating what he's incorporating into his theory, and also the way he explained this is a part in the whole process, and I'm trying to speak to this part explicitly. I thought that was sort of nicely aimed at least. But yeah, any kind of initial feelings people have about this paper?
I thought this was a cool paper. I agree that I appreciated how like well he situated himself in the larger project, saying like this is what I'm going to do and why. I also liked that. So he focuses on this one concept, resonance, that he sees as kind of having been left behind. Like there's a lot of philosophy in cog sci now that kind of followed from Gibson, but he's saying like that this contemporary like current philosophy and science could benefit from a more rigorous examination of this other concept from Gibson. Like information has gotten more attention, but this not so much. So what I started saying last time was I feel like there's a sense in which so he doesn't explicitly talk about mechanism, but I think what he is trying to give is a mechanistic explanation in a sense. Like telling the story of how resonance works is part of a mechanistic explanation. So on the bottom of 32 and beginning of 33, he says, without such a theory of resonance, of like exactly how resonance works, without such a theory, ecological psychology fails to offer a true alternative to computational explanations. And I guess I'm asking like, well, why is that the case? Why would this part of the explanation be necessary? And I think my like first answer is because a complete explanation involves a mechanistic explanation, as defined by the last paper we read. And so Raha doesn't say that, and he says things against like computational mechanistic explanation in particular, but I don't think, I guess, we could also pick apart his use of computation. But I think that there's definitely, I think that what he's after here is an explanation that falls into the category of mechanistic according to the previous paper. So then at the top of 33 says, the system that enables the agent to behave in the way that she does must be explained. And that, okay, yeah, so that enabling is like exactly what the last paper talked about at one point. Mechanisms enable or sustain the process.
This is going on here. Yeah, I hear you with that. I was gonna say a similar thing about he uses I think it says kinematics. Yeah, behavioral. The model itself aims to neither describe neither ecological neuroscale, but is targeted to an immediate scale of behavioral kinematics. Is that he is talking about his theory here, right? My theory. Or is he talking about like this other thing? I think he's talking about his theory here. All of these examples for plausibility of resonance at the explanatory level like the model I proposed in 3 and show that we are able to develop concrete models like graphs that are coupling between the two scales relevant to an account of cognitive phenomena in terms of resonance. Which, whether or not he achieves this goal, I feel like nice effort towards it, at least in the way he's framing it. I get it, like I understand why he's doing it, and like I see the need he's trying to address, at least in the equity. An operational, naturalistic characterization that enables ecological psychology and dialogue with contemporary neuroscience. And that's on page 30. Okay, so let's just go to this here. We're kind of are pretty much there. He talks about computationalism. He situates he's situating it against it's neurocomputation for cognitive architecture and contemporary neuroscience. The ability to arrive at mechanistic description of inner states of systems. And that is a description of the role of the nervous system in cognition. And he talks about, computational is contested by an activism, ecological psychology, Schummer's radical nature, sensory motor account, and dynamic systems. Here's again. Disregarding their success in criticizing the computation for explanation of their ongoing paradigms. However, they all lack a satisfactory account of the role of the central nervous system and periphery nervous system in cognition. An account of neural computation and cognitive architecture is able to neural computation as a cognitive architecture law. Okay, since this is a continuation of that.
Yeah, sometimes people leave sentences in here. I've noticed that going through papers, kind of like, I don't think that's a full sentence.
Right.
Yeah.
Draft.
Yeah.
Should be a semicolon, basically. Yeah. Then he talks about resonance. The only reference to the activity of the brain is through this resonance thing. So that's why he's.
So
where is the definition he gives of resonance? It's down here somewhere, right?
Yeah, he quotes Gibson on 33, and he says this is like the only place that this idea appears. the whole system of input and output resonates to the external information. So it's very vague. But then he interprets that as meaning that resonance is characterized as the proper activity of the organism regarding external information. And the brain seems to have a chief role in it. So still, like, the starting place is fairly vague, and I think that like the rest of the context of what ecological psychology is necessary, which is why he then goes into these constraints on developing the concept of resonance, like what boxes does it have to check to still count as Gibsonian. And that's when he says, well, obviously, I think he actually says the word obviously it can't be computational. 34 at the top, obviously, to explain what is going on at the intra-organismic scale with regard to the ecological scale, in terms of computation, would violate this tenet. The tenet being that perception is direct and there's no information processing. But then, and I think I said this last time too, my first response to that is, I don't know, after we've talked about how, like, the different forms that computation can take, I don't think that that's so obvious. I think that there's a type of physical computation that you could call direct perception still. So I don't know how much that, like, matters for him here, like what counts as computational and what doesn't. Like, I guess I don't know what the pros would be of arguing that this view does actually count as computational, just this particular, physical analog whatever version. Like, I'm not sure what benefits would come from that, but I definitely don't think that it's obvious that computation violates that constraint.
Right.
And he doesn't say that much about what exactly he means by computation, but the impression I got is something like symbol manipulation or something involving representations.
Right. What does resonance mean? I mean, I know what it means, but, like, it's kind of like when you say resonance, it has to resonate. I mean, like, what does that mean? Like, a string can resonate on a guitar, and but so what is he getting at? Does he have? I didn't see that he had a definition of resonance that was maybe something we could make an operational assumption about, like, it's this thing in the world.
Right. So I also think it, like, kind of came out slowly through the paper, what resonance was supposed to be. I think that the existence of, like, of variables that are like this tau variable, that seems to connect the environment with the agent in a somewhat linear fashion. It's like the same variable appears in the equations that govern the agent's behavior and things in the environment. So I think this definition of resonance is, like, fundamentally a dynamic systems theory kind of explanation.
Right.
Like, the definition will look like not a particular set of equations, but that kind of description of the interaction between agent and environment. I like that figure, the first and second figure.
Which one?
No, before neural reuse, it was page 32. Not that that's super helpful in defining resonance, but it's something describable by differential equations that happens in the nervous system, but is importantly coupled with ecological information.
Okay. Let's go back to those equations. I want to see something. I guess it's down 39 or so.
Here, I think these ones.
Yeah. So what is he doing here? He is saying A minus E sub D, which is sort of the agent environment scale, N sub D, which is the intraorganismic scale. That's the CNS. So it's like basically inside the organism. They're coupled equations here, and they're functions, so they're sort of like, I guess they could be coevolutionary in a way, but he doesn't state that. But then he states in the next equation, this chi equals this thing, which is ecological variable times sort of it. So it's intraorganismic dynamics. So he's kind of defining an internal model in a way. So he's saying there's an ecological variable and then k, which is not sure what k is, but k is a linear constant. Given that our abstract model of resonance for some psychological task would be this coupled equation, so you have your you can actually put in the term in the, so you have a coupled function again, but they're sort of connected together. They're basically the same function, but one has a linear constant. So then you have this. So I guess that means that they're very similar in terms of their structure. They basically track each other if you were to plot it out. And so they're linearly coupled in terms of the ecological variable, which is, yeah. And so they're, I guess, I don't know why they're coupled all of a sudden. I guess it's just if you say it's in resonance or not in resonance.
Right, like when you're resonating with something,
Yeah.
you're perceiving something, it involves this kind of coupling. Which is interesting because other people we've read have talked about like structural similarities and isomorphisms, and I think this is getting at exactly the same kind of thing. There's some linear relationship between agent and environment, such that there's like a pattern that shows up in both.
Congruence.
Yeah, congruence, I guess, yeah.
Yeah.
So, yeah, I guess they're two scales, but they're actually, well, I guess they're two scales, but they're not like temporal scales. They're just like, they're inside the organism and the outside the organism. So that's where you get like, you have to put things into the equations and say, this is what I'm talking about. So the ecological variable being something that you could measure in the environment, like a signal, and then chi is a variable that defines the intraorganismic dynamics, which mean well, that's an internal model, which is like, it could be like simple sensory motor coordination, say. So that's a nice linear feedback model. Or it doesn't have to be linear, but now as when n resonates to A-E, these two functions are coupled. So now there's this resonance condition or just kind of a control condition where we don't assume resonance. So that's interesting how he sets that up. So that means your sensory motor feedback, your control is now resonating with the environment. So you're maybe coordinating your dynamics with the outside environment. You're able to respond quickly versus not. And I don't know. I don't know. The way of setting up equations, sometimes they're more conceptual, and sometimes they're more like, you can map it to a specific measure. So that's a thing. And I don't know. I mean, I like the way it's very actually. We do have this in our Gibsonian Information work setting it up. I had no idea this paper existed before we got it in this group. So it's kind of like, it's very similar in the way it's, well, not really the way it's set up, but just having equations for it. But they're different. So let's see. This figure 4 actually shows our, this is time, of course. SWF, I don't know what that means. Visual angle of loom. I guess this is just kind of like an example. This is looming, which is like this, when you have a thing that's kind of coming into your field of view. That's visual angle. We'll look at it over time. So as the visual angle of loom increases, it increases over time. The rate of change for visual angle, I'm in part B, rate of change of visual angle of loom it's a different way of looking at it, degrees per second minus 1, which is basically the inverse. And there's a different, but it's a similar kind of increase. Rate of change, so it's like, it's a decimal and it goes up accordingly. It's interesting. So the source waveform is SWF. Okay. So the source waveform might be like a signal coming in. You could say it's a waveform like, it's like a vibration, or it's like intensity of light, and you have a sort of a signal that has or an auditory waveform, and you can actually decompose that into parts. But this is the waveform. It's just kind of raw information coming in. It goes above 0, it goes up to 200, and then down to like negative 200. And so you have the same thing here. You have rate of change, which is the fraction, SW of x, which is the number for the waveform. It goes up and down like that over time. So he's saying in A that this is the neural activity in the visual angle. So you're actually looking at the visual angle of the stimulus, the neural activity, and then you have a tau value, which is, there's a tau value of the waveform. So does he define tau in terms of what is he using it as? Oh, here it is. Tau, the ecological variable, is time to contact between, let's see. Yes, yeah, time to contact.
Oh, sorry.
Yeah. Between visual, between the approaching object and the visual system. So this is kind of like sort of lag, the way people use tau in, like the way differential equations is to use tau as the lag factor. And these, like, if you have something that's lagging behind something else, if you have to introduce like a lag, it would be like if I said something and you didn't hear me for like 3 seconds, that tau would be that length of time that you don't hear me. So those sound waves don't hit your ear for 3 seconds, and it's just like a gap in time, and you can characterize that with tau. What he's saying is that this is almost spatial, where you have an approaching object in the visual system. It's a time to contact, so it's that you see an object, and there's this visual, and it goes into the visual system, and it's incorporated in the neural activity. So that's okay. I guess that's what it means.
It is like 2 cars example, and one's like 2-dimensionally smaller, but you understand they're both the same size. So is that, I think he kind of gets into that at some point.
Yeah. So yeah, it's I guess it's processing, or we don't really have like a, like relativity is not really a factor because we see things pretty instantaneously at like room scale or something like that. If you were like looking at an object from outer space, of course you don't see that light. Like if there's a star that's emitting light, you see in the night sky, you're seeing what was there, many years ago. If it's maybe like 10 light years away, you're seeing what was there 10 years ago. That would not, I guess that would also be tau, but that could be some sort of lag factor. But I think here he's talking about processing, the processing time being maybe even trivial, but if I need to like kick something away from me and it's coming very fast, that tau could be pretty important. I don't know. It's kind of just thinking about it like that. So yeah, that's what is the citation for that tau parameter?
This one up here.
Yeah, right there, or Lee 2009. So that's
General Tau Theory, Evolution to Date, Special Issue Landmarks and Perception.
I didn't know there was a tau theory. I'll have to read that. It sounds like, I thought you meant like, it sounds like General Tso's chicken. I'm like, what is General Tau theory? I'm like, really? I don't know if there's a specific tau theory, but yeah. I mean, that's pretty interesting.
So, okay, any more about this? There we go, I back up a little bit in the paper. Such conflict quantify, which fits the abstract model, I present in the last section where conflict between the two dynamic systems as a linear relation between the main variables of each scale is described. Like in some studies, so that phi is the variable that specifies the relative phase between two oscillatory components at different scales. This is the collective variable. Oops.
This is, I don't know if you remember when I did this stuff on coordination dynamics and I talked about Kelso. They do this, they use phi for like a lot of their coordination. So it's like you have two oscillatory components. They're kind of coordinating, they're sort of in sync or not in sync. And they're using this phi as part of the sort of the dynamical plot. So yeah, I mean, I don't know if you remember any of those plots, but they're like, they have like these symbols on the axes, and it's like, what does that mean? So that's what phi is. But that's, yeah, so it's a gate, tapping, gate, or interpersonal coordination. Like if I tap on a table, you have to tap on a table alongside me, and that's the coordinate, the coupling there is the phi. So it's like tuned to some variable, and it could be like, if you have two sinusoidal functions, they're sort of like either they're overlapping or they're what they call antiphase, which is where when one is at its maximum, the other is at its minimum, and they go up and down like this. And then that would be, in between there is where your phi would be. So you have these two different measurements of phase angle, and it's basically the same thing. So, yeah.
I have a whiteboard drawing of something like that that I can't explain. Points to the biological plausibility of resonance. How do we feel about that?
The example that was particularly illustrated for me was in I think it's the next page. Musical rhythm and entrainment. Yeah.
Yes,
So here the ecological variable is the rhythm, and there's an influence of that ecological variable on the brain's rhythm, on the intrinsic oscillatory dynamics. So that was I found that helpful. I guess this is the case with the other examples too, but this one just seemed simpler. An example of how the thing in the environment, like there's a pattern in the environment, and that very same pattern is created in the brain. There's no like twisted representation. There's no like, 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 there's computed like other variable. In this case, there's just the same pattern. There's the beat and there's the brain oscillations.
Mm. Oops.
The fractal DST stuff I felt a little above my head. But I guess I see why that would be the route to go for exploring these things rigorously.
What can we try to break down this diagram, because I didn't quite get it myself. This is the model used by Rugby. Based on a model of bipedal locomotion, it incorporates neural rhythm generator A and muscular skeletal system B. Behavioral emerges by the modulation between these systems happening during C. Oh, here. Okay, down here, yeah. Let's see. What Rugby et al. Include in the transformation of tau to the modulation to see if it helps the prediction of the foot pointing dynamics during walking. The enhanced model actually predicts foot pointing dynamics better than Taga's one.
What's your question, I guess?
Oh, I don't know. That's fine. I don't have any specifics, I guess, right now.
So the global states are the movement of that walker. So like when your feet move, you have these different phases of movement. So you put your foot down, you swing your other foot, you put it down, you swing your other foot. That's what they're getting at here with the right and the left. So those things have to be coordinated or else you'll fall over. The muscle groups, of course, are these synergies. We talked about this as a classic example of synergies. So they all work together to make sure that the leg swings and the foot hits the ground, and there isn't like this overpowered movement that or if there's like a banana peel on the ground, you could slip, but you want to maybe control that you don't hit that very hard and not slip. So this whole thing in A is like the sort of the posture controller, which controls the posture, generating things to the muscles, commands of the muscles, their inputs from the environment. There's feedback from the limbs and things like that, and then of course visual stimuli. So if you see the banana peel on the ground, you can avoid it. You can swing your leg around it, or you can not produce a lot of force to hit it very hard. So I mean that's basically what they're getting at. And then these muscle groups, which are the circles with the numbers, those are all basically like the synergies. So all the muscles in one leg work together so that you don't have to think about, okay, how do I position my knee joint? Do I have to get it to a certain number of degrees? And then how hard do I need to hit the ground? And then what does muscle 10 say versus muscle 20? It's all coordinated as like a synergy. And so that all moves distinctly given the signals that are being sent to the nervous system. And then the physiology of the muscles is such that it can handle that kind of activity. So they're all coordinated. What's interesting is if you took away, like if there was a muscle that was injured, like if you pulled your hamstring, or if you lost muscle mass in your thigh, you actually have a gait that's not like that. It's not synchronized, and you have like these movement disorders, and people study them like in terms of gait, so they can tell like if someone has a problem with their leg or something, then you'll see it like this map in C will look different. You'll have like trouble coordinating your movements, and you also, if you have noise in the nervous system, like, you know, an occluded cerebellum or some dysfunction in the motor system, you can also have problems maintaining your balance or walking in this way. So it's very much it's a very good system for like looking at a lot of these things.
One thing that's interesting in this context is, so I'm understanding this graphic as there's this neural rhythm generator, there's something central, and from that there are these other dynamics.
Right.
So there's the central thing and then other systems that are coupled with that, and in the end you have, you know, a gate.
Right.
But if that central thing is, so maybe it doesn't just give rise to these movement patterns, maybe it's involved in cognition more profoundly. Maybe it's involved in like something like the your self-other distinctions, or I'm thinking because in various like psychopathologies, you see movement disorders corresponding to, you know, like thought disorders. So I'm wondering if I don't know what this would look like, but if that same like central, in this example, like rhythm generator, if whatever the thing at the center of the picture is, if that could lead to like the physical behavioral dynamics, but then maybe also cognitive dynamics.
Yeah, I think the neural system is just stuff. It's like a sketch of the things that are involved. But there is actually, in a lot of animals, you have the central pattern generator thing that's like, it's usually actually in the, in insects, it's in the notochord, the central sort of nervous system going to the legs. So it's like this set of neurons, like a network of neurons that fire, and they're synchronized, so they fire in a sort of in a chain, and it's circular, so it generates this rhythmic output, and so you can measure the rhythmic output. I think I actually have some data that we were working on a little bit for stick insects, where, you know, they have like a central pattern generator at the base of each set of legs, and then there's this you know, rhythm that's established so that the legs just kind of move like this, and so then the insect is moving, walking along, and then that rhythm just needs to be modulated somehow by like a neurotransmitter or something, and it can slow it down or speed it up, and then that's basically what you have here. We have like central pattern generators in our nervous system, like our heart is a rhythm. We have other kinds of rhythmic generators, but the central pattern generators are really interesting because it's like the set of neurons. It's like just the whole point is to create a pacemaker, and it just kind of goes, and then it can be modified by things like, you know, any sort of neurotransmitter or like other types of inputs from the environment. They say visual motor controller. So these squares are kind of very vague with respect to the brain structures, but that's basically what's going on in this internal model. So this is like if you were building a robot maybe, but you do see this in biology, especially like in invertebrates. Central pattern generators are very important because they help. It doesn't require a lot of like neural tissue. It's like maybe a couple of neurons, but it generates this pattern that's durable and persistent.
And is that specific, like, central pattern generators, are they specific more so to, like, insects or certain parts of, like, tree life? Or is it more like everything has them? It's just different weights they have?
Yeah, I think, well, we have a pacemaker for our heart. You know, we have, and then other, like, mammals and vertebrates have, like, pacemaker neurons and other types of structures like that. We have like you know, autonomous sort of pacemakers in our brains. If you look at of course, you know about circadian rhythms. That's sort of a pacemaker system where you have this rhythm that's established, and it's like entrained to light. So you have this you know, rhythm, or this rhythmic generator, and then you entrain it with like environmental light, and it can entrain the period of it. So it's like the output is like, is it like, as a cycle every 10 hours or 12 hours, you can entrain it to light, and, that sort of thing. So we have them in our bodies, but yeah, they're pretty important in terms of like invertebrate neurophysiology, because they use them quite extensively, and they're probably the best understood, because you can cut open a living insect, or even like in C. elegans, they're central pattern generators. Nobody really cares if it doesn't have a backbone. I pretty much don't care what you do with it. But yeah, but that's so those are like I think a central part of this is like this neural system where you have this. It's circular, so it's circular causality. There's feedback there, and it drives this pattern that gets renewed, I guess.
I've just found a few citations that talk about central pattern generators in the human spine.
Yeah.
They're maybe more controversial for humans, but if it exists in other vertebrates, then it makes sense.
Yeah. And of course, that's not the central nervous system, that's the peripheral nervous system. Or, well, I guess it's sort of beyond the brainstem. So that's interesting because, people talk about like a lot of cognitive science is about like the central nervous system. And then you get into like neurophysiology, people are really interested in the peripheral nervous system. And it's like, well, that does play a role in cognition, because, if you think that everything's embodied, then the body is going to play a role in that. Like, that part of the nervous system is going to play a role in that as well. So,
yeah, it's a really interesting discussion, honestly. I feel like all these citations with like the Charby stuff that I need to look more into, Ruji, and everything else is kind of like, and Kelso and them again. Okay, I feel like it would really behoove me, which is a word I never use, to really look at all the citations here. I feel like there's a lot of really rich. This is like top shelf in terms of the richness of relevant, like associated ideas and hopefully references. But yeah. Okay. Depending on how much more we want to go, we have potentially 5 minutes to 25 minutes left. Yeah.
We're almost done with the paper. Let's finish. I don't want to have any left over before we break.
We were basically in the DSD part of it. Actually, before we get to that, I think we've got everything that I wanted to hit. I want to check resonance. We're pretty familiar with the anti-computational stuff. He does a nice job of it here, where he kind of uses the Alfred example and the thing about is it just moving relative to internal states or not? Different reasons. A lot of good footnotes in this paper. Poverty is stimulus, and Chomsky talking about here. Poverty is stimulus, is that the one where it's basically not enough? Let's see where
yeah, there's like the reality is underdetermined by what you can get from the environment.
So it goes into that. Contrary to poverty stimulus argument, one of the foundational things of ecological psychology is the richness of stimulus. Right, okay. So he's kind of juxtaposing these different views and kind of, if you will, the offloading relative to other views, but like that there's information, there's stuff in the environment. We don't have to compute it. Remember this, we don't have to compute it. We just have to kind of be exposed to it. And we don't have to do these really advanced calculations just to get it to it. Not to create information, but to find it. I think it's a nice quote there. So yeah, hear a lot about that. And he talks about this other I like this part where he kind of relates physical system to, like, I think he concludes something like the whole deal is part of it. It's just what part are we going to look at for this? It reminds me of something from another paper where it's like, I think in a previous, maybe the previous paper with Lee or the one before it, but by saying when we're talking about cognitive stuff, we understand there's a lot of things that are playing into the cognitive processes, but it's not necessarily that every specific aspect of it is completely, fully, a cognitive determiner, but more it feeds into that, or it can be associated with the system, but just not of the substance or the magical, I don't know, what, it is not directly part of it. Yeah. Ecological psychologists reject the assumption that inner states of the organism must play a preferred role in explanation, visual event, or other special events. In other words, they hold to an ecological explanatory strategy. There's only one causal chain. He gets quite clear about this. It requires the rejection of any kind of inner feature as the realizer of the target phenomenon. Nothing special happens inside, thus thinking in terms of the chain of computational events, etc. So yeah, he kind of goes over this stuff here, and he tries to develop his own ecological cognitive architecture and goes into neural reuse. I don't know if I think we kind of touched upon it, but does anyone want to say about neural reuse itself? I think this is the discussion about like components and then, not.
Yeah, we're just Michael Anderson's version of neural reuse. So where do we have this the top here? I just wanted to see where he brings it up. He doesn't talk about kind of what this version is, does he? Because neural reuse is like the idea basically is that you have a network and then you'll change the function of the network. And you can use the same network, you can repurpose it for different things. Like if I have a network for, say, like detecting a visual stimulus, I might also use that network for associated things like, processing other types of visual information. I might reconfigure it a bit. I might, if there's a different type of visual processing needs to happen, I just use the same network. This is like, something that, I don't know if you want to put it in terms of a neural network, but it isn't really about the weights, it's about the sort of the topology itself. So he's like throwing a lot of like things in here, like Bayesian predictive coding, semantic pointer architecture, kind of ACT-R. Well, actually, ACT-R is a good example of like all those examples are all these computational cognitive models that fail to sort of conform with his model here. They're not ecological. So like ACT-R is like a classic cognitive architecture where you have these boxes and arrows and you have like this very classic cognitive thing where it performs this task and you have like, the task is defined and there's a lot to it, but basically it runs on this idea of process and defining things in the world, and they're not very flexible, but they do model certain tasks pretty well. So what he's saying though is that there's this, and I don't really know why he picks Michael Anderson's version. I guess it's probably the most relevant here. But yeah, so neural reuse is an organizational principles for the functions of the brain. Its core tenet is that different parts of the central nervous system, so you could have neural networks, individual neurons, you could have like a neural network for vision, a visual stimulus, like processing, and then you could have like a central pattern generator. You could also have one for inputs of motor control. And so then you have those, they're used and reused to accomplish different functions. So this is like ACTAR, where you have these modules for different things in the task. That's only for that task. If you want to do something else, you can't really easily. You have to reconfigure. You have to get a new model. This is where you can reconfigure your network in different ways, and that allows you to reuse the same model in different ways. And then so it's achieved by soft assembling of different parts and different functional systems. So this is basically, people talk about neural reuse and neuroevolution a lot because when you have differences between species, oftentimes it's a matter of like, if you have a new behavioral function, they'll use like an ancestral pathway and they'll just modify it. So you don't have to evolve a whole new pathway for something. You use, I think we talked about this a couple of times in the past, where you might use a different pathway for a new function. You might evolve a new behavior that you've never seen before. You don't need to evolve a whole new part of the brain, or you don't need to evolve. Sometimes you have that, but oftentimes you can build upon what's ancestral and build up from there. And so and when I say build up, I don't mean like, it's just that it gets built on it. So, yeah, this is kind of, I think we mentioned neural reuse in our Royal Society paper, which is kind of interesting because I didn't know about this paper, but it's very much, I think a lot of the things in our work are very parallel to this. So,
it seems in the same spirit, like trying to give a rigorous definition of this ecological psychology concept.
Yeah, and even to an extent, well, yeah, I'll leave it at that. I'll move on so we can finish this paper up. Do you want to say anything about this diagram? I didn't pay attention to it that much. Talks about modularity and just different ways of relating.
So yeah, that's neural reuse right there. If you have like your different parts of the brain that you want to configure for a task, or maybe just for like a function, and then you have different tasks that you want to do, you could just reconfigure how it's wired, and it's not like ACTAR where you have to like define functions and then task specific functions, and it's kind of like the difference, but sort of like the difference between like good old fashioned AI and like neural networks, except he puts neural networks in that category of things that don't work well either, because in neural networks you don't have like the topological aspect. It's just kind of nondescript and there's no representational component. Now here he's not saying that there's a representational component, but you could have like kind of a low level of representation. You could imagine like these areas maybe represent certain relations, represent certain things in the brain that are going on. So, if you connect two things, that means that there's kind of a representation of what's going on in the environment versus not having them connected.
Yeah, I'm glad you brought up representation, because thinking about that tau variable and how the ecological thing and the brain thing like align, the same pattern appears in both. That seems like a nice definition for representation, like whatever is happening in the brain, where there's that clear linear relationship between the brain thing and the environment thing, like that. Let's call that a representation. That doesn't seem problematic at all. Like there's a version of representation that fits well with this resonance theory.
Yeah.
Yeah. Okay, and then I think we're right back to the diagrams here. So a little bit out of order, but here we are. And then we went through all this stuff, and then we're at DSD. And it's not that different from this. By fractal analysis, I refer to the tool that opens the possibility of addressing the relationship between relevant scales in terms of fractals.
That is how structural properties at higher scales are found in smaller scales as well. Very interesting.
Oh yeah, he mentions self-organized criticality too.
Sure. So multi-scale fractured DSD, fractal TSD is the right methodology for the study. I don't know if you have any thoughts about the DSD section.
No, I feel like I got the gist.
I'm mostly kind of abridging this because I think we kind of talked about radical embodied cognitive neuroscience, but that's basically the conclusion of this paper. Those aren't really conclusions. Just hey, check out this kind of implementation of this implementation space. I thought it was interesting that he mentioned the NSF, the grants here earlier in the footnotes as well. So I'm not looking at that. And we also have World here. I think that's the same person you mentioned before.
Oh yeah. Yeah, I thought that was neat.
Okay. And then Kelso again. You can active search. And yeah, so grand challenges in brain mapping. And again, he concludes with this idea of his theory, his version of resonance theory can help us out. Okay, so we made it. I think we can say we covered the paper. I really want to go through the references. I feel like there's a lot of just from Cherby to the Anderson stuff that I don't know that well, and everything else. Good stuff. Any concluding thoughts for our last Cognition Futures meeting for a while in general?
This made me want to read Gibson too.
Yeah, fair point. Exactly. I'm going to copy these keynotes because they're very important. Okay. Yes, I've got keynotes of the banana peels and avoiding them, and then General Tao's chicken. What do we want to read next? We've covered so much stuff. There was a bunch of things we mentioned before. I know we have some of the books, like the cybernetics books and the other books that are kind of on the docket. We're kind of on this train. It's been a really interesting train. The last 3 papers have been a really interesting kind of story arc almost. Maybe we don't have to decide right now, but maybe something I can kind of put together some options and think about it over a time away, or return with things in our minds and go from there.
Yeah, I'll think about it.
Yeah. Okay. Next time is basically break. So are we gonna? We're not having a regular meeting next week. Is it going to be are you going to be back for the next one after that? I forget. I keep this up to date, and I start to keep asking you. I forget.
I will be back. So I'll be gone for
a month.
3 weeks. I'll miss the next 3 weeks, but I can be back on the 16th.
Okay. So for at least 2 weeks, we'll be not having this May meeting. Sounds good. That's great. I'll leave it. I'll make things a bit later, but I'm happy with this. We compared to other things, we spent less time on this paper, but I feel like there's a lot to. I think that I'm going to keep coming back to this one and also the mechanistic one earlier too. But I feel like this paper is a really nice. Like this feels like an actual synthesis attempt to push forward. He's taking a couple people's ideas and he's saying, okay, I think this fits here, this does this. It's a good. We talked about like the synthesis paper versus like building on ideas. I think it's a nice reference for that, even in a sense of it, things we can try to aspire towards when we get especially towards the top of our own paper pyramid. I think it might basically look similar. Getting towards something like this would be interesting. So.
Yeah, I liked how he ended with saying like, and this is the kind of stuff we can look for in science using scientific investigation. We can explore this theory more. It didn't feel stuck in philosophy world.
Cool. Yeah, I like that. Great. I'll let it be for that. Thanks everybody for their time tonight. I know we kind of had a lot going on in general, and it'd be nice to have a break anyway for our summertime. I'm happy with that too. Hope everyone has a good time away, and I'll see you next month maybe or in a little while.
We'll see you tomorrow.
Oh yeah, tomorrow. Yeah.
We make it to that.
That's true. We'll see you tomorrow. But in my mind, I'm still in Cognition futures. All right. Take care, everybody. I'll see you at some point in the future.
Have a good break, Amanda. We'll see you tomorrow, but after that.
Yeah. Talk to you soon.
All right,
Thanks.
talk to you soon. Bye.
Take care.
Take care.